Hey guys, how you doing? So I'm going to take a look at 2.5 today, and this isn't a big jump from what you've been doing. We've basically got two terms that we have to learn, and then we have to learn how to be able to make our own triangles from word problems. And I don't think that's going to be a big difficulty for us. First thing we need to know what an angle of elevation is. The angle between the horizontal and the line of sight up to an object. Angle of depression is going to be the angle between the horizontal again and the line of sight down to an object. So let's say I'm sitting here on this boat and I'm looking out straight ahead of me. So my horizontal is going this way. That's my horizontal. So I'm here, there's my horizontal. However much I need to look up to be able to see the airplane. So this angle in here is an angle of elevation. It's how much I had to move my eyes upwards to be able to see. Now, if I was up here in the plane, then my horizontal would be going perhaps this way. That would be my horizontal to the ground. But I would have to look down to see the boat. So it's the downward angle. This would be my angle of depression. No, it's not just a sad angle. It is an angle of depression, like you would a depression in maybe the floor, and maybe you would talk about a depression in a floor where if you rolled a marble, it would go into that sort of hole that was made from the horizontal. And once again, the angle of the elevation, think of elevator going up. So this is the angle of elevation. Okay, so we have some word problems here. The height of a tree is 6.2 meters. From a point 8.5 meters from the base of a tree, determine the angle of elevation to the top of the tree to a nearest degree. So somebody's gone ahead and drawn us a tree here, which is very nice. Personally, I think a straight line is a better idea for a tree. It's going to look more like a triangle. This is going to be the base of the tree, and we're going to be, according to the information that they gave us, 8.5 meters from the base. There's the base of the tree, so I'm going to be out here somewhere 8.5 meters from the base. We're going to assume that the tree makes a 90 degree with the angle. That's going to be an assumption for all trees, flagpoles, buildings, anything like that. And they're telling us that the height of the tree is actually 6.2 meters tall. So that's going to be the height of the tree. And they want us to know the angle of elevation. So we need to draw that in. So this is our horizontal. This will be our angle looking up to the top of the tree. So that will be my angle of elevation, and I'll just call it theta for my unknown angle. So then I have to look at this triangle and figure out what I need to come up with. I need to come up with this angle. According to this angle, this will be the side that's opposite that angle. This will be the side that is adjacent to that angle. And this is our hypotenuse. Nobody really cares about the hypotenuse, and if I'm able to come up with this angle without knowing the hypotenuse, that's perfectly fine in this question. So what uses opposite and adjacent? The answer, you got to remember from the earlier lessons that we've done, opposite and adjacent is looked after by tangent. Tangent of any angle is equal to the opposite side length divided by the adjacent side length. That's a formula. Put a box around it. So we're after the tangent of theta. In this case, opposite is 6.2. Adjacent is 8.5. That's a ratio. We're after an angle measurement. So the angle of theta is equal to tan inverse. And I would write the fraction, not the decimal, because the decimal is going to be a lot of numbers. So let's do 6.2 divided by 8.5 equals, that's the decimal equivalent to that fraction. Second function tan, and I come up with approximately 36 degrees, rounded to the nearest degree. So therefore, angle theta equals approximately 36 degrees. And that's how you do that. So here's another question. We have an angle of depression from a plane to an airport is 25 degrees. So here's our plane. We're assuming that the airport is somewhere along the ground. The angle of depression, well, we have to think about that for a minute. If the angle of depression is from a horizontal down, we have to think about that plane as having this horizontal. If it was to keep flying, that would be its horizontal. And the angle of depression is going to be here. So, there's where my angle, there is my angle of depression. If the altitude of the plane is 10,000 feet, determine the direct diagonal distance from the plane to the airport, rounded to the nearest foot. So this is the distance they want to know. I know that my plane is actually 10,000, I believe, feet off the ground. Yep. Here's the ground. So here's my airport. Here's the height, 10,000 feet. We're going to assume that the plane's directly above this point right here. This is the ground. And we know the angle of depression is 25 degrees, so this angle out here is 25 degrees. So, what do we want to find out? We want to find out the diagonal distance from the plane to the airport. So we're after this distance right here, which is going to be the hypotenuse. What do we know? Well, we know this side, but this angle is outside the triangle. We need to get that information inside the triangle. Now there's two ways to do it. Do you see this? This makes a 90-degree angle. That means that this is 25. This must be 90 minus 25. So we can say 90 minus 25, and it is going to be 65 degrees. That is one way that we can do this question. Another way that we can do this question, working with this 25, is to say, well, this horizontal and this horizontal are parallel, and you'll remember from grade 9, we have what we call the Z pattern. And we see this Z pattern, and whenever we have that Z pattern between two parallel lines, we know that this angle and that angle will be equal to each other, which means that this will be 25 degrees. Now, if we're right, everything inside this triangle should add up to 180, so we'll do 65 plus 25 plus 90, and we get 180 degrees, so we're right. You don't have to get both of these angles, but you have to be able to determine at least one of them. Now, you pick one of the two triangles to work with. Let's say I wanted to work with the 25 inside here. Then I'm going to say that that's the angle that I have. That would be opposite. That is hypotenuse. Which trig ratio uses opposite and hypotenuse? Well, that's going to be, and we need to memorize this, opposite and hypotenuse is sine. So sine of 25 is going to equal 10,000 over x. Okay? Now, that's sine of 25 over 1. This is x. If we cross multiply both sides, we get x times sine of 25 equals 1 times 10,000. If we divide both sides by sine of 25, we get x equals 10,000 over sine of 25. Using your calculator, I'm going to do 10,000 divided by 25 sine equals, and I come up with approximately 23,700 662 feet. Now let's see how I did that again. So we had 10,000 divided by 25 sine. That's not the answer. That's the decimal for 25 sine. I have to hit equal, so it does 10,000 divided by that decimal, and I get my answer. Okay, so a number of things in that question to pay attention to. One of the first things I'm going to tell you is that if it asks for an angle of depression, you must show me this angle of depression outside the triangle. And then either put it inside down here by doing the Z pattern, or work with the 65 degrees and you'll get the same answer. You'll use a different trig ratio because then it would be adjacent in a hypotenuse, which would be the cosine, but you'll get the same answer. Okay, let's flip over and finish this question off. Example 3. Two buildings are 41.6 meters apart. So this distance here is going to be 41.6 meters apart. From the roof of the shorter building, the angle of elevation to the taller. So from the shorter building, I'm going to be looking up to the taller. The horizontal to get that angle up is going to be right here. There's that horizontal. So this is my angle up from the shorter building to the taller building, and that's 44 degrees. Then the angle of depression to the base of the taller building. So from the same area, so the angle of elevation, so hold on, let's go back. From the roof of the shorter building, the angle of elevation to the top of the taller is 44, and the angle of depression to the taller one is going to be 29. Using the same horizontal, but now it's an angle of depression because it's going down. Both of them are from the roof of the shorter building, from the same place. What's the question? Find the heights of the buildings to the nearest tenth. Okay, well, I see a bunch of triangles. Here's one triangle. I'm going to put a 90 there. This is 41.6. This angle out here is 29 degrees. So I've got two choices to use this 29 degrees inside this triangle that I'm looking at. I could say that this whole angle would be 90. So that'll be 90 minus 29. So this will be 61 degrees right here. The other choice is to notice that this line is parallel with this line down here, and we get that Z pattern we were talking about, which means that this angle here is 29 degrees. I have enough information to be able to determine the height of this building. If I want to call that X, then I can look at this angle and say that I've got opposite over adjacent from this angle. Or I could work with this angle and I could say that I've got opposite and adjacent. So both of them work. So what I think that I'll do is I'll start with the sine of 29. So step 1, I'm going to keep my work neat. And I'm going to name this triangle A, B, C. So in triangle A, B, C. So I use the little symbol so I don't have to write out the word. In triangle A, B, C, I'm going to say that I have opposite and adjacent. So opposite and adjacent is tan. So I have tan of 29 degrees equals X over 41.6. I'm going to cross multiply. So I get 41.6 times tan of 29 equals X. So I've got 29 tan times 41.6, and I get an answer of approximately 23.05, so 0.1. And do we have a unit? Meters. So that was to the nearest tenth. Now when they say tenth, they mean 1 decimal. If they said hundredth, then it would be 2 decimals. So we've answered the first question. We know that the height of the first building is approximately 23.1 meters. Now that means that this building is 23.1 meters, which means up to this point will be 23.1 meters. So if I could find out the extra little bit that's up here and add it to that, I would know the height of the entire building. Well, looking at this triangle up here, and I think I'll name it. I've got a B over here, so I think I'll call it X and a Y. You can just barely see that Y if I draw that in there. This will be a 90 degrees, and this is the triangle XYB. So step 2, I'm going to say in triangle XYB. Let's see what I've got here. Well, this length here is going to be the same as this length here. So this is still 41.6. I have an angle, and I'd like to find out this length here. And I'm going to call that little b, because it's opposite the vertex B. So I'll call that little b. So using this angle, that's opposite, that's adjacent. What uses opposite and adjacent? Tan does. So tan of 44 equals b over 41.6. Let's do the cross multiplying again. This is over top of 1, so I'm going to cross multiply. 41.6 tan of 44 equals b times 1, which is just b. So it's going to be 44 tan times 41.6, and we get approximately 40.2 meters. So therefore, the taller building is 23.1 plus 40.2 meters, which is 63.3 meters tall, approximately. And the smaller building is approximately 23.1 meters tall. There you go, ladies and gentlemen. So that's word problems and the idea of angles of elevation and angles of depression. So you got some homework, get working on that, and we'll be looking at you guys sending me any questions that you have over the weekend on the email, and we'll be looking at maybe some Kahoots on this and a little bit of extra work on this on Monday. So get this done over the weekend, and Monday we'll have a little bit of assessment on it from there. Okay. Talk to you soon.